Okay, in this chapter, we're gonna hear words like union, intersection, difference, and complement very often. So I would advise you to memorize the definitions of A union B, of A intersection B, the difference of B minus A, and then finally the A complement. Okay. In order to help you understand and kind of like visualize this, I'm gonna draw some Venn diagrams over on this page. Okay. So the first one is gonna represent the union. Okay, so as you might imagine, the union of two sets A and B is basically everything inside of A and everything inside of B taken all at the same time. So the union of the sets will be everything that was inside the blue bubble and everything inside of the red bubble. Okay, so all of this stuff that I'm drawing is considered to be the union. So you're in the union of A and B if you're an element of A or an element of B. You're considered into the element of A and B. Why did I draw my picture the way I did? What does each of these things represent? So first of all, the little rectangle represents the universe. This is the world that my sets A and B live in. The sets A and B, I made them overlap a little bit because I'm not sure if they overlap or not. So I took the general case where they actually overlap. So like I said, the union of A and B is everything inside of A or everything inside of B. Now, what about the intersection? So let's do that over on this page. Okay, so the intersection of A and B is the common section between A and B. So on this picture, it would be that little area between A and B. That would be considered the intersection of the sets A and B. It's basically the common elements to A and to B. So normally we write something like X is in the intersection as long as X is in A and at the same time X is inside the set B. That's what we call the intersection. Okay, so is that clear? Okay, now what about the set difference? Again, let's scroll down a little bit and put the set difference over here. Okay, so what do we mean when we say the set difference of B minus A? When we're talking about B minus A, we're talking about all the elements that were inside of B, but not already inside of A. So basically, it would be that little moon-shaped area. It's basically everything inside of B that's not already part of A. So you are considered in the difference if you're in B but not inside of A. So we write that usually like this. We say you're an X in the difference as long as you are inside of the B but not inside of the A. So and not inside of the A. X is not inside of A. Okay, and last but not least is the complement. So the complement, I'm gonna do that here too. So what do we mean when we say a complement? It's basically everything outside of A. So in this case, we don't need a second set. It's pretty much all of the outside of the A. So it's basically the rest of the universe. It's all of this, but not the A itself, okay? So it's basically every X, as long as the X that you pick is not already in A. That's what we call the complement of the set A. So I'm gonna go ahead and do an example where I use these words, and here are the numbers. It says find A union B, A intersection B, A minus B, and B minus A. So A union B. So A union B, remember, is all the elements of A and all the elements of B written in one spot. So I'm gonna write down all the elements of A, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And all the elements of B that I didn't already write down already here. So -2 is new, -1 is new, 1, 3, 5, 7, and 9 have already been written. We don't need to duplicate them. That's it, the end. Now what about A intersect B? By the way, I forgot to say here, this is the same thing as B union A, right? The order B union A or A union B is not gonna matter, and we're gonna have to prove that in a few minutes, but that's still true here. What about A intersection B? So for the intersection, again, you're gonna be thinking to yourself, I want all the numbers that are already in A and B at the same time. So I want the duplicates, basically. So 9 is showing up both in A and B. 7 showed up both times in A and B. 5 showed up in both of them. 3 showed up in both of them. 1 showed up in both of them, and that was it. Those were the only numbers that showed up in A and showed up in B. So I'm gonna write down the list: 1, 3, 5, 7, and 9. These are the intersection. It's the common elements. Okay, what about A minus B? So what does A minus B mean? It means I want all the numbers that were in A but not in B. So I want all the things that were in A, but not in B. So was 1 in B? Yes, so forget it. Was 2 in B? No, so write it down. Was 3 in B? Yes, forget it. Was 4 in B? No, write it down. Was 5 in B? Forget it. Was 6 there? No. Was 7 there? Yeah, forget it. 8 is brand new. And that's it. 9 was already in B, so we are finished. So this is the A minus B. Okay, so we're taking all the elements that were in A, but that we cannot find in B. And finally, the B minus A. So this time it's pretty much the same story, except I'm looking at the set B and I'm asking, is -2 already in A? No, so go ahead and write it down. Is -1 already in A? No, go ahead and write it down. Is 1 already in A? Yes. Same thing with 3 and 5 and 7 and 9. So they were already in A, so that's it. The B minus A is just the elements -2 and -1. I hope that made sense.